So this is the erbium energy level diagram. Here, basically, we are using two photons having wavelength 980 nanometers and 1400 nanometers. And due to spontaneous and stimulated emissions, we are getting the photons. And we have discussed this in last video. And this is the happening inside the optical amplifier. So we are discussing the EDFA. So basically this is the EDFA architecture. So in this you can see that there is a three configuration in which EDFA can be used. So here you can see that there are different components while configuring this EDFA, that is optical amplifier. So signal in and signal out, these two are the optical signal. This is input signal, this is amplified output signal. And there is a pump laser, there is a OI is a optical insulator. Then there is a optical tap couplers. This TAP, this is the couplers, optical couplers. So what are the role of this optical couplers? This optical couplers compare the incoming signal and the amplified output signal. So basically this tap optical couplers are present at the both end, at the receiver end, at this receiver end, and at this transmitter end. And here can see this is the optical isolator. And what is the function of this optical isolator? This optical isolator prevent the amplified signal from the reflecting back to the device. So this optical isolator separate this signal from this. Here you can see this is optical isolator. So this is the output signal that we are receiving we will get from this optical isolator, and if this signal is reflected back, then it can harm the input device or create attenuation distortion. So in order to prevent this to stop this reflected signal to reach back to the device, we are using this optical isolator. So what we can say? We can say optical isolator prevent the amplified signal to reflect back to the device from where it is generated. So this is all about the different components used while the configuring EDFA. What are those components? Tap couplers, optical isolators, pump, EDFA, again OI and tap. Now here you can see there are three possible configuration. So the first one is known as a co-directional pumping. Second one is a counter directional pumping, and third one is the dual pumping. So what is the meaning of this co-directional pumping? So in this co-directional pumping, the pump line, this this pump light is injected from the same direction of the signal flow. So here you can see this signal is the direction of signal is this, and the pump laser is injecting the light in the same direction. So this is co-directional pumping. What is happening in this B? In counter directional pumping. So in the counter directional pumping, this is the direction of optical signal, and the laser is injected or power is injected is opposite to this signal direction. So this is counter directional pumping. Pumping action is opposite to the signal propagation. Here pumping action and the signal is in the same direction. Here both are in opposite direction. And in case of dual pumping, you can see in this case this is co-directional pumping, and in this case this is counter directional pumping. So in the C type of configuration, that is in dual pumping, we are using both the configuration. So these are the three different ways in which we can configure our EDFA. So now next, this is the gain versus pump level. So what is this is P pump. So what this graph is indicating, so if we are increasing the input power at particular pump level, so what is the meaning? Suppose this is pump level 53.5 milliwatt. So at this pump level, we are considering this pump level, and if we are increasing the power, then we obtain almost constant amplifier gain till the saturation. After saturation, this the power, the gain is decreases, but we are getting constant gain for a particular time. So this is a gain versus pump level diagram. So this is all about the EDFA configuration, architecture, and relation between gain and pump level. Thank you.